Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P0712 and P0713, indicating issues with the automatic transmission fluid temperature sensor in the Honda Pilot models from 2016 to 2022. These diagnostic trouble codes signify either a short circuit or an open circuit in the sensor circuit, which directly impacts vehicle performance. The ATF temperature sensor plays a critical role in monitoring transmission fluid temperature, which is essential for optimal operation and performance of the engine and transmission system. This guide will address potential issues related to these diagnostic codes, detailing symptoms, possible causes, and systematic troubleshooting steps to effectively identify and rectify the problem. Remember that these codes point to electrical circuit issues rather than mechanical problems in the transmission, making it crucial to focus on electrical checks during troubleshooting. In detail, DTC P0712 corresponds to the ATF temperature sensor signaling a short circuit, while DTC P0713 indicates an open circuit condition. The ATF temperature sensor is typically located within the transmission housing or attached to the transmission fluid system to effectively monitor the temperature of the transmission fluid. This sensor is crucial for ensuring that the transmission operates within specified temperature ranges, preventing overheating and other potential issues. If the transmission fluid is too hot or cold, it can severely affect the vehicle's shifting performance and overall drivability. Understanding the placement and purpose of these components is essential for targeting the diagnosis effectively. Both codes signify electrical issues rather than mechanical faults, which localizes the troubleshooting process towards wiring and connections within the electrical system. The primary cause of DTC P0712 and P0713 centers around an electrical circuit issue. This could manifest as either an open circuit or a short in the wiring associated with the ATF temperature sensor. Specifically, the TATFM, Transmission ATF Temperature Monitor, and TATFP, Transmission ATF Temperature Signal wires are often the culprits, as they are responsible for relaying temperature data from the sensor to the Transmission Control Module, TCM. Failures can occur due to insulation damage, pinched wires, or poor terminal connections that may impede proper signal transmission. Moreover, a malfunctioning sensor unit itself may trigger these codes, particularly if the internal components are compromised. Therefore, accurately diagnosing the precise nature of the fault is crucial for effective repairs, emphasizing the need to check these electrical pads carefully during the inspection process. When these trouble codes are present, several symptoms may be observed, primarily exemplified by the illumination of the check engine light on the dashboard. This alert serves as an initial indicator for the driver that an issue exists within the vehicle's transmission monitoring system. Further manifestations might include noticeable transmission performance issues, such as delayed or erratic shifting behaviors, which can compromise the vehicle's drivability and efficiency. The automatic transmission may not shift at the appropriate RPMs if the fluid temperature isn't being accurately reported, leading to potential overheating or other complications. Additionally, drivers may report strange noises or sensations during gear shifts. Effectively addressing these symptoms through appropriate diagnostic measures will mitigate further damage and enhance overall vehicle reliability. The initial step in troubleshooting requires turning the vehicle to the on mode, which allows the onboard systems to activate and communicate any error codes present. Following this, it's essential to clear the diagnostic trouble codes, DTCs, using the Honda Diagnostic System HDS tool. This step resets the system, enabling a clean slate for further diagnostics. After clearing the codes, you must turn the vehicle off and then start the engine, waiting for at least 10 seconds while in the P park position. This brief waiting period allows the vehicle's systems to stabilize before checking for any pending or confirmed DTCs once again with the HDS. If either DTC P0712 or P0713 reappears, it's indicative of a persistent failure, warranting deeper investigation. Conversely, if no codes return, intermittent failures may exist, necessitating checks for poor connections or loose terminals between the sensor and the TCM. The second step in the troubleshooting process focuses on checking for open wires in the circuit related to the ATF temperature sensor. Start by turning the vehicle to the off or lock mode. Next, you need to disconnect the TCM subharness 26P connector and the TCM 58P connector. This disconnection is critical for safely testing continuity without interference from other circuits. Then, with the vehicle in the off mode, check for continuity between specified test points. The TCM subharness 26P connector number 25 and the TCM 58P connector number 30, as well as between the TCM subharness number 26 and TCM 58P connector number 17. If continuity exists, this indicates that the TATFM and TATFP wires are intact, allowing you to proceed to the next step. However, if there is no continuity, you will need to repair the open wiring between the sensor and the TCM to resolve the fault. The final troubleshooting step involves checking for shorted wires, which could be responsible for the faulty readings being sent to the TCM. With the vehicle still in the off position, you will be checking the continuity of the TATFM and TATFP lines to body ground. Disconnect the same connectors as in the prior step for accurate testing. Measure continuity between the TCM 58P connector terminals, specifically number 17 and number 30, individually against the ground. If continuity to ground is detected, it indicates a short circuit condition, necessitating immediate repair of the wire causing this short. On the other hand, if no continuity exists, it signifies that the wires are functioning properly. In this case, the next logical step would be to replace the ATF temperature sensor unit, since it may be malfunctioning, thereby not providing accurate readings to the TCM. After completing the necessary repairs and replacements, it is essential to verify the integrity and functionality of the system thoroughly. Begin by carefully reinstalling all previously disconnected connectors to ensure a secure and proper connection. Next, clear the DTCs once more using the HDS tool to reset the system. Once cleared, it's critical to initiate a retest of the vehicle. While operating the vehicle, monitor the performance and check for any returning DTCs using the HDS. The aim is to confirm that the issue has been entirely resolved and that the transmission operates under normal conditions without dragging performance. A successful verification ensures that the repairs have mitigated the faults associated with the P0712 and P0713 codes. To prevent the recurrence of DTCs, P0712 and P0713 in the future, it's prudent to adopt a regime of preventive maintenance focused primarily on the transmission system. Regularly inspecting the wiring associated with the ATF temperature sensor can catch potential wear or damage before they lead to circuit failures. Furthermore, ensuring that all electrical connections, particularly at the sensor and TCM, remain tight and secure will eliminate many common electrical issues that lead to these codes. Monitoring the transmission fluid levels, including regular changes, helps maintain optimal operating temperatures, thereby reducing stress on sensors and extending their lifespan. By integrating these practices into routine vehicle maintenance, you can significantly reduce the likelihood of trouble codes appearing again, ensuring reliable transmission performance. In conclusion, understanding DTC's P0712 and P0713 is crucial for maintaining your Honda Pilot's transmission health. These codes are specifically linked to electrical circuit issues stemming from the ATF temperature sensor, which is vital for the smooth operation of your vehicle's transmission. The core causes often revolve around either open or shorted wiring or a malfunctioning sensor unit. The outlined troubleshooting steps are designed to methodically isolate and repair these electrical faults, ensuring accurate readings and reliable transmission behavior. Moving forward, incorporating preventative maintenance practices will go a long way in safeguarding against future occurrences of these DTCs, enhancing the reliability and longevity of your transmission system. This guide serves as a comprehensive reference for effectively addressing these error codes in your Honda Pilot. Please like and subscribe to the channel. See you next time.